need 2 tubes, right? So if you don't have 2 tubes, you will put a balance with water on the opposite side.
Okay.
Right? Never run the centrifuge unbalanced, you'll cause it very much damage. So we take these 2 tubes, and we're going to transfer it, because in this case we do have cells, we're transferring anyway, let's just transfer cells into both of these. Whenever you wash, the key thing is that you need to suspend the cells. Whenever you dilute, you also need to suspend the cells, because you need to make sure that you are taking an even sample out of your whole thing, right? So, you just can see that there is nothing important, right? Okay, so we'll put equal amounts in both of those. We don't actually need very much. Let's do, but I want to have at least a visible pellet when we are washing. So I'm just going to put 500. So this is not actually washing, yeah? Just so you know, this is when you're actually washing, you'll have something to wash. Right now I'm creating something to wash.
Okay.
So this is not really relevant to the protocol per se. So when you want to change medium, so for example, for a lot of our experiments, we start with exponentially growing cells, which is to say that they have everything they need to grow. But then afterwards, we're transferring them into a condition where they're starved of something. And between that, you'll need to wash them. It's not enough to just pellet them once, change the medium. You need to make sure that they've actually been washed a couple of times, so that there's a good chance that any nutrients sticking to them have been washed off.
Okay.
So anytime you're basically changing a medium from plenty to not plenty, you will need a wash.
Okay.
If you're going the other way around, you can add things and it's not, you might need to wash that from ST and YPD are both plenty, for example, right? Like, so you might want to wash it going to ST for the one reason that ST is still less plenty than YPD is, right? Like, so, and then the other reason is that YPD is colored, and you might be using optical density measurements in your experiments, and so that might be a reason you want to get rid of it. But when you're going ST to YPD, the one problem you can have is that you will end up diluting your YPD with the ST in that. So in that case, you might want to not really wash, but just pellet the cells once when you do the change.
Okay.
So washing, the difference between washing and pelleting is that pelleting is just one step of a wash, right? So you may, if you really want to wash, you will do multiple rounds of pelleting.
Okay.
But pelleting is all you need to do any change of medium to the cells, without diluting the medium with mixing different mediums, essentially.
So pelleting will be just like centrifuging it once.
That's it. Yeah. So once you centrifuge, change of media. That's one change of media. Washing is you centrifuge thrice, change the media. That's the only difference there is, right?
Okay.
Okay, so we put some amount of cells in there, and I'm going to put some amount of water in there. Let's just take out sterile water. And I would not advise doing more than 3 milliliters in these tubes. Maybe it works, but there's a chance you'll spill when the centrifuge tilts, right? Like when it's spinning.
Oh, okay.
It like I'll show you when we go there, but the tubes will be tilted this way, and you might end up spilling things beyond a certain volume. So anyway, these are not good for cultures beyond 3 because the aeration is really bad at that point. But actually, that's not maybe I have some here. So I put 500 milliliters, so I'm just going to put 2 milliliters of sterile water. We could do less, actually. Reaching over the flame when you're working with the flame. Organization is just not optimal for that.
Open what before doing what?
The Falcon tube is
Okay.
easier to, like, sometimes it's hard to open with one hand. So you want to loosen the lid. I think Manning might have shown you she does that standardly. Loosen the lid before picking up the pipette. 3 milliliters. I'm going to put 1.5 in each so that we have a total volume of 2 in each. I have not taken 3 milliliters. I took 4, sorry. Now,
So you put 2 in each?
yeah.
No. Yeah. Okay.
We have measured this, right? Like we put 500 milliliter measured, we put 2 milliliter on top. You can still see difference in volumes, which is honestly a bit surprising, but it might be because the tubes are slightly different. The point is, I would not trust the measurement for running the centrifuge. I would always weigh the tubes to make sure they're matching. And for that, it will sometimes show an error. That's just because you've zeroed it to a very high value, but
Okay.
don't worry about it. It's not going to be a problem. Right. That makes more sense, right?
Okay. Yeah.
So now this is 0.3 less because the specific gravity of water is 1 gram per milliliter. You know that 0.3 grams is going to be 300 milliliters. So what I can simply do is I remember that this is the blue tube which was less, and I'm going to add 300 microliters of water to it. This calculation only works when you're working with water, right? So if you're not working with water but you're working with ST or something, then you don't do as precisely. Add a little less because the specific gravity of ST is going to be higher than water. The other way which we cannot do with sterile cells is that we drop on the balance, like we put liquid on the balance so that we can see how it's changing.
Okay.
But we can't do it with sterile cells because it needs to be sterile. And that you could take the flame there if you really wanted, but I think it's kind of easier to do with this. So if this was ST that I was diluting with, I might not have added 300. I would probably have roughly added 250 and seen how it goes. Just kind of check there a little. So it takes a little trial and error. So remember that it was blue. We had that. And I'm taking time to demonstrate this, but washing has to be a pretty fast process because this is kind of a stage where the cells are
Like not
in
happy.
some intermediate stage, you know, which your experiment is not. It's not a clean thing for the experiment. So you see that it's
Both are 0. Yeah.
So you don't want this process to be very long. Oftentimes, if you just like look, you'll also see that they're much more similar now than they were before. So it's just okay. So this is the centrifuge. There's a switch. If you come around, there's a white switch on this side that needs to be turned on for it. This is what it's for 15 ml Falcons, but our tubes fit into that. Our small tubes fit into that. So if you have anything bigger than that, do not run it on the centrifuge. You may end up crushing the tubes.
Okay.
Because, like I was mentioning before, so for the centrifuge we only take these insets out. And we put the same thing on both sides.
Okay, check if they both are the same.
They should be.
Okay.
I mean, because this is kind of standard size. So sometimes what can happen is something is stuck inside and that makes it heavier, but I don't see anything stuck. So I probably am just imagining it. The better way of weighing, if you are in doubt, is you could take this and you could weigh the tubes in that directly on the balance, right? But I don't usually do that. So now what happens is that when the centrifuge is running, all of these tilt inwards.
Okay.
When the centrifugal force, right? So your tubes are going to tilt inwards. and this is why you don't fill them more than 3. I know that 3 works, 3 is fine. And the other thing is you cannot use tubes taller than this because it will crash to the
Okay.
center of the rim, right? So like, okay, then you position the tubes roughly in the same spot, so on the opposite side. So it's not super important that they're in the same spot,
Mm-hmm.
but I try to keep them sort of equal. Right. And this is Marcia. Where are we? Okay, so our protocol actually says that we should do 200 RPM.
200 or 2000?
I'm sorry, 2000.
Okay.
2000 RPM for 2 minutes. I once made a mistake and I started to use 2000 G, which is higher than
Mm-hmm.
2000 RPM. But then for consistency, I kind of stuck around. So the way this worked is that I just chose which one I am on. I went to RPM. I had to click twice, and then the knob allowed me to change it. Sometimes the knob is on this one is a little shifty, so you might, like, even if you're going in the same direction, the numbers might sometimes increase. Just,
Okay.
be persistent. And then you press RPM again and it's selected. So now what it's saying is that it's running 2000 RPM for 2 minutes. Program identity is not important. Temperature is set to 25, which is basically not setting temperature in some sense, so like it's not going to do much regulation. That means fast acceleration and fast deceleration. So
Okay.
if you wanted to do a slower ramp up or slower ramp down, then you could change this from 9. 9 is the maximum value it's set to. That can, so basically I think people do that when they're working with sensitive things that they're worried about breaking.
Mm-hmm. Okay.
Everything is set. Press start and hope that you don't blow the thing up. Volume matters less than how many times you do. But diluting something, it's basically a process of dilution, right? You have some bits of medium sticking to the
Mhm.
cells, you're trying to dilute it out so that's insignificant. If you diluted 1 in 10 in one round, the maximum dilution you've achieved is 1 in 10.
Yeah.
If you diluted 1 in 2 every round, but do it thrice, you've done 1 in 2, into 1 in 2, into 1 in 2. So with much smaller volume, you've got to 1/8,
Mm-hmm.
8 times dilution. So basically, 3 into 10 dilution is 1 by 10 raised to 3, so
Mhm.
1000-fold dilution.
Yeah.
It's not the same as a 1 in 30 dilution, right? Like, so you can take that same 10 ml and you add it at the same time,
Mhm.
you only get 1 in 30 dilution.
Yeah.
But if you do it repeatedly, you're
You
getting
get
1 in 10 every time, so it's like you get a much better feeling. So the number of times is quite important. My rule of thumb is to go with the volume that the culture originated from for the volume of the per wash. So in the sense of the culture was a 3 ml culture, I will add 3 ml each time for washing. I'm not fixated on it, so sometimes I adjust it just for ease of handling.
Mm-hmm.
Like I said, the number of times you wash is more important than the volume.
And it's always 3 times.
I usually do 3 times.
Okay.
If
Or
you,
like if you have like a higher volume, would you do more washes?
higher volume of cells.
Yeah.
If you have a higher volume, I would rather keep the volume high but still do 3 times.
Okay.
So that's why, just so I don't change both parameters.
Mm-hmm.
But if you were really particular and you were worried that your cells were not getting washed, like if you saw in the behavior that the cells were still sort of seeing, not getting stopped and things like that, then you could try increasing more. I've seen from before, the problem is it depends on the nutrient. If you are washing off carbon source, they will immediately not do anything after that. So
Mhm.
as soon as you look at them, after that the OD flattens out. If you wash off a nitrogen source or sulfur source, you'll see a slight increase before the OD flattens out.
Okay.
So you can't really tell, but because I know that carbon washing it's enough to do this much, then I know that actually in principle the other washes should be enough. So it's hard to be absolutely sure. If you're very concerned about making sure that everything is washed, you could increase the number of times you wash up to 5, I think. You have to be careful that, like I said, you're increasing your handling time. So the balance is between the handling time and that. You know, like you don't want to be washing cells for 1.5 hours. The cells just don't know where they are, and they're just constantly being thrown into a centrifuge, which is not a pleasant place for them to be in any case.
What would you do? Like, what would be the like target time that you wanna do with it?
I really try to minimize it as much as I can, because this is 2 minutes per run. You cannot minimize that. So 2 minutes into 3 will be there. If I'm really good, I can do it maybe 15-20 minutes.
Okay.
But half an hour, I would not want to exceed more than half an hour,
Okay.
ideally. You can see that the cells are at the bottom, right? Like,
Yeah.
So sometimes you will see that the liquid above is not as clear.
Mm-hmm.
This particularly happens if your volume is very high. So, for example, if you're using a 50 ml Falcon and you have 25 milliliters, sometimes that wash is not enough.
Mm-hmm.
I add a minute.
You would add. Okay.
But you know, be aware that you will end up. That centrifugation is not enough. Be aware that you're stressing the cells extra every time you do that.
Okay.
Alright. So, getting rid of the liquid, right? Like, so, we basically just dump it here because it's faster. If you will lose a few cells every time you do that. So if you're really close on your cells, you might want to pipette it out. But
Okay.
I usually just do this. The trick with doing that is the tube is going to be open, and it's a sterile tube. It's not a sterile environment. So the trick to that is make sure it's not upright when it's open. So in the sense that it should be facing
Because
down.
it doesn't. That way it doesn't. Okay.
Yeah, so things don't fall in at least, right? And then the other thing, so basically keep it open for the shortest time possible.
Mm-hmm.
Be inverting it immediately after removing the cap, and then give it a pretty tight jerk. It should not be like, like don't be lingering in that step, don't be slow while it's upside down.
Mm-hmm.
And usually what we've observed is that if you do one quick dump and then do another quick give it a jerk there, it'll get rid of more liquid than if you just do one.
Mm-hmm.
But everything has to be super quick.
Okay.
And if I'm worried about losing cells, I sometimes don't do the second tapping, and just to avoid it. Okay. So tube gets open.
Okay.
Right, and you see that the cells more or less stay there.
Mm-hmm.
There will be, like I said, some loss, but it's not very much.
And is it fine, like, because there's still some liquid in there? Is that fine?
Yeah, so that's the balance you have to find. If you try to get rid of that, you'll lose a lot more cells. You can already see that the cells are redissolving in that liquid,
Yeah.
right? So if you try to tap that more, you will do that. So again, you go invert, one jerk, that's
Okay.
it, right? And you try to kind of keep this consistent across that, and you don't want to touch the open. So for this one, I accidentally touched the open now, the tube, not being very careful. But you want to avoid touching anything. And so the whole processing should be really quick at that point. You can, like I said, be more precise and then dump the liquid out using a pipette instead. It's just, like I said, you're always balancing between the time that this process takes and the efficiency you achieve with it. And, that much liquid from how much we started with is very
That's
little.
good.
Like I said, you're diluting it, every round. Okay, so the reason I kept the flame on was because this is how you will actually do it. Like, it's taking long because I'm explaining right now, but usually you'll keep the flame on, you come back here because you quickly add liquid, you go on with the rest of the steps, right?
So you would add more water.
I'm going
and
to
do it
add
again.
more water. Yes, but before that there'll be one crucial thing I do. You know what that is? Changing media on top is not enough. You need to make sure that the cells have actually been suspended in the medium. For each step of the wash.
And you're not touching the inside of the tube, so you can reuse it, right?
Yeah.
Okay.
I mean, in principle, I could reuse it anyway because they're the same cells here. But I'm just showing you how you do if you were not.
Okay.
If you were working with different things. And if you were only working with one tube, the other tube would be water. And then you just it's a lot easier, of course, to do that because then you can just adjust the water to whatever level you need. You don't have to do it here. It doesn't need to be sterile. You can just go there and
do
put
that.
in
Okay.
as much water you need. So it's a lot easier to do that, but it's not that effective. So you can see that I added water, but the cells are still at the bottom, right?
Yeah.
So this is why the vortexing step is really important. Otherwise, the cell pellet will not really get a good rinse, and nutrients might be trapped between the cells and the pellets. So you have to make sure you resuspend cells. Resuspending, I have noticed, works better if you do multiple rounds of touching rather than touch once for longer. Right?
Okay.
So you do have to check that happens.